Let me share this with you guys. Okay, cool. So, good question. You know what? If you can just do 1,000 indirect for this right now, because right now we're not like physically working on the actual stair. I mean, we are, but we aren't. Like, that's fine. And just make sure that when you go back to what you're doing after this, that you go switch back to the 4200 drafting for this one. It's always easy to forget that. So, hmm I know. Um, Maybe I'll take it back. Maybe we'll look at AbbVie real quick. So again, we did, or sorry, yes, AbbVie. We did a mock-up for each one of these. Jake Stalker and I worked together on these. We had Kevin's involvement too. So that mock-up is currently in the shop being worked on now, which I did get a chance to see last week. That was pretty neat. Um, it's not like it's probably like halfway done at this point, but that's all right. So this one I have a pretty good grasp on though. This is the AbbVie one here. Um, Spiral staircase, of course. But really, the purpose of today is mostly just going over how to how to kind of like get the helix right and how to draw that in AutoCAD. So me, yeah, I think that's what we ended up doing. Um, Unless there was a reason, like a place that had it, but I think we ended up trying to estimate it at this point. I mean, once you do have like the real CAD file, you'll have actual information to go off of for that, so that'll be a little bit easier. Um, um, yeah, it's the opening that they're showing there, unfortunately, I think. Oh no. Mm-mm. Yeah. Well, in the case of this one, we're waiting on the CAD just so that way we have like a solid foundation to go off of first. So what I was going to do is look up the mock-up that we currently have, but I was going to show you guys how to do this here. So one thing you can kind of see, like you kind of start with really what you want to start with is your section view first. So like anytime you sweep a model, it's pretty much the same deal. You want to have a model that has a bunch of closed polylines. So anytime you have something like that, it's like each piece of geometry needs to be closed. If I click on that and go into properties, you can kind of see that they are. If you're dealing with something that's not, it's not going to sweep it as a solid. It'll actually sweep it as a surface, which I know you guys pretty much all know that anyway. But just a reminder because it is something that like you're gonna like be like, don't if you do that and forget. So yeah, anytime you're sweeping anything, it always has to be closed polylines. So with that being said, like you can either use bpoly to do that, you can use the J for join and just close your polylines that way. But yeah, you always want to start by drawing your 2D section view first. And I mean, they don't really give you one for this staircase. So what we ended up doing was we kind of made some estimates based on like Kevin and Jake and Keaton's discussion. Um, and we did a few like little hand sketches on here for them to look at. And then we ended up making like the actual like kind of mock-up section here. Now, this isn't going to be like a full blown like section for this because right now I'm still missing things like the glass and the actual handrail that goes with it too. Um, but they really just needed to see the panels for this, which is why it looks kind of like this because we're just seeing the two little stringer caps up here, and then the wraps that go around the stringers, and then you have a panel that runs underneath of the stairs on this one. And I think the same is for um, Evershed too. I think it's a very, very similar staircase design, um, where it's going to have panels around the stringers and then panels underneath of the stairs too. So this is brand new for on-site as far as I know. We may have done this in the past before I started here, but as far as I know, I think this is the first time we've ever attempted to make veneer panels underneath of a staircase like this. So it's going to be kind of a weird one. Um, but, what else is new? So, okay. When you're dealing with a helix, though, there are a few things you want to keep in mind that you're going to be needing here. Um, the thing is, you really want the radius. So that is like the number one thing. You want to know what your radius is that you're going to use as your sweep path. Usually I'll either pick the inside curve or the outside curve, or in some cases you might need both, depending on the staircase, but most times it's the exact same profile going up and around both sides of the stairs. So in our case today, that's kind of what we're dealing with. So we do need we need the radius from the, I'll just write these out here. We're gonna need the radius for one of the curves. So we need that, which I don't think they give us that. So we're gonna estimate it today just for purposes of looking at this. So we need radius. We need to know, um, it sounds silly, but we need to know the angle between the start point and the stop point of where we want the helix to start and stop. So angle between start, oh, I did that in lowercase for some reason. Angle between the start and stop point of the helix. That's going to tell AutoCAD where to go. So that's kind of the next thing that you need is the height change from point or start point to end point is how much of a height difference are we talking about? So a lot of times you can get that based on like the stair treads themselves because you kind of already know like my treads are this tall. And so like I can do the math and figure out, well, if I have 11 treads at like 6 and 7/8, then I know how tall my helix is going to end up being from the ground to the landing above. That's what I usually do is I'll go because like clearly like here I could do a helix that goes all the way around to here, but most likely, and I don't know if their axial view shows it at all. Oh, this view does show it. It does flatten out at that landing right here. And that's gonna, yeah, you would have to do it. Exactly. So you have to do it in separate parts because you have more than one helix. So you got a helix up to the landing flattens out. That's just a basic run of the mill. You're sweeping along a regular flat curve. Well, that didn't sound right. You're sweeping around like a two-dimensional curve, I guess is what I would say. And then again, you go back up to another helix, and then you have another sweep going up there. So you'll have to do them separately. I guess you could maybe join them together, but I've never really tried that. But we can give it a shot too. So those are like kind of the three things that you really need though, is you need to know one, my radius, two, the angle between point A and point B, and then you need to know the height change from start point to end point. Mm-hmm. Yeah, like, mm-hmm. Let me see if I can, there we go. I was trying to get rid of that. So I made these markups earlier just to kind of get an idea of what we're talking about. So the start and stop point in this case, like what I ended up doing, well, this is kind of tricky because the stringers go all the way down to the floor, whereas the treads do not. The tread's going to stop a tread shy of the actual floor height down below. So as you go through and you pick your start and stop points, you do want to be kind of careful about that. Um, what I did before to get that angle though was I went from well, let me see if I can turn on my snaps to content. That's what I need. So I was gonna say what I ended up doing before is I took a line here in Bluebeam, snapped it from edge to edge of tread at the front of that tread nosing, and then I used the shift key and extended it up like this. So it's going straight across. Because right now you can't see it because that dumb text box is blocking it. So, so you have to kind of know where that is. So what I did was I kind of did this, and again, this is probably arbitrary because like normally you wouldn't need to do this. Normally they're going to give you that information. Um, but in a case like this is a very like preliminary drawing that they gave to us for the stairs. So once we have the CADs, I don't know why that's not working now. Once we have the CADs though, we should be able to actually get an actual angle, like a legit angle off of this. But right now what I'm going to do is knowing if this is what I'm treating as my start point here at the corner of my tread, and this is what I'm treating right now as my end point at the bottom tread, but not the floor yet, I can kind of find the angle between the two. If it's not given to me, what I would do is try to use the scale to do that. And if I don't have a CAD file, obviously this is what we have to do to make it work. So we're gonna go, yeah. Oh, yeah, yeah. Mm, yeah. So I'm using this as my endpoint up here where the last tread stops, and then this is my start point down here right now. So I would say make it as precise as you possibly can. So like what I was going to even suggest is like here, if I can, I'm going to set it as low as it'll let me set it. Because we're going to have to do some math on this to get the angle to, because like I'll explain that when we get into the AutoCAD portion of it. But it's important to note what the angle is, but we still have to do something different with that in order to tell AutoCAD how many, because the angle is determining the number of turns that you're going around this radius. And right now, if I type in 145, it's going to think I'm telling it needs to go around the circle 145 times, which is not accurate. So, yes. hmm hmm Well, when you get to the top part, let's say like what we're talking about here is like your curve actually kind of stops here at this intersection. hmm Yeah. So yeah, you're good. I would end up doing kind of the exact same thing for up there, but I would measure from that point down to like this point essentially and just get that angle, which is going to end up being different, but um not that I recall, but I wouldn't doubt it if it does happen at some point in the future because, these things are all super custom. Um, so, okay. So now that we know what the angle is, um, one thing I would say is start point, end point of helix. So we need to know the height change still. So we got our angle. Let's try to figure out what the height change would be. Um, when I did this with Jake earlier, we were able to sort of determine this. I can't remember how did we do it. I think I measured, yeah, you can see what I did was I measured one tread and elevation to see what it came out to. And then I think I double checked the math because they give us the height from the floor to the bottom of the landing panels. So after I swept it, I checked that and it ended up being all right. But if I know, like, let's say this is correct, that the tread height is 6 and 9/16. That's actually pretty normal height there for stair tread. So 6 and 9/16 is 6.5625. And then we need to count how many treads that we're moving. So starting with, let's see, here we go. I guess starting with 5/16. Sorry, I'm just trying to make sure I'm doing this right because like I was debating whether or not I count that or not. But I'm going to start here. 1, 2, 3, 4. Whoops. 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13. So technically, like here, I could keep going, and that landing would kind of be like another tread because it's going up another 6 and 5/16 or whatever that was there. So you could count that too, because technically, if you think about it, you still have to move up. I'm trying to see if there's a view that shows it. Maybe the Axio view might have it. Yeah. Mm-hmm. Exactly. I wish that there was a better view of it, but your treads kind of stop here and then your landing is actually like here. So I'm counting the landing as another step, even though it's kind of not, but it kind of is. Um, yeah, they usually do. Yeah. So I'm going to take the tread height and multiply it by 14 to see what my height change is from, should be from the floor to the landing then at that point, which looks like it's 91 and 7/8. So 14 treads times 6 and 9/16 is going to be 91 and 91.875. So I'm going to write that down here too. So let's just write down what we have right now. So we have the angle at 145 and 91.77. 145.917. Yeah, yeah. The only reason I have the decimals so far out is because it actually makes a slight difference when you draw the helix. It might make it like a 32nd or 16th off if you're not being extremely precise on it. It's really weird. So, yeah, you want to make sure the angle is as far down as you can go with decimals. In AutoCAD, it's a lot easier because you can go down to like 12 places or something crazy like that. But in Bluebeam, it looks like it only goes down to 4 or so. Um, so you need the angle, which we have. We need the height change, and that is 91 and 7/8. Okay. And then the last thing we need is we need to know what the radius is. So radius, I mean, we might have to guess, which I hate doing, but we might have to in order to make this work. I'm trying to remember how I got it before, how I figured it out. Yeah, I guess you could do that. Um, yeah, there is. There is. That's right here. That is right there. Mm-hmm. Mm-hmm. No, unfortunately, this is one of those cases where they just didn't really give us much to work with. Um, So until they get us a CAD file for it, I mean, for the mock-up, it was no big deal because we're just mocking it up. For this, it's kind of more important. I'm gonna see what I ended up with before, so I could kind of get an idea of like how I got to there. 107. Okay, so let me see if I could figure out how I did that. 107. Oh, you know what? I Yeah, yeah. Mm-hmm. What's 8 foot 11? That's 107. So that's perfect. That's what I had. Yeah. So what I did was I could do that center point method and pull a measurement off that center point, but I went to my Bluebeam measurement tools, and I know there's a radius one that's here, but it's terrible. Um, there's one here if you click on the arrow next to it, that's a 3 point radius though. And if you use that, you can just click on 3 points on a curve and it will actually calculate the radius based on those 3 points. So I don't know why it came out different that time. That's weird. I'm gonna say it's 107 because that's what I had before, but yeah, I would rather have the CAD file for these stairs so I would actually have a legit able to pull a real radius off of it. But just for the purposes of like practicing this today, what we're gonna do is we're gonna start by drawing because let me write that down too. So radius equals 107. Okay, cool. So that's our math over there. Let's save that so we don't forget it. Okay, so looking at our CAD file, let's pretend that this doesn't exist because that'd be cheating. Um, what we're going to do is from the top-down view, we're going to draw in a circle with a radius of 107. Okay, and then from there, what I want to do is, let's see, I probably need to draw in a line to represent the start point. And I know this isn't exactly lined up with where they have it, but just for right now, it's kind of what I'm gonna start with. So I have a line here from the center of the circle straight to the edge, just snapping to the quadrant. I'm gonna make a copy of that line and paste it right on top of where I had that one. So just like that. And then what I want to do is I'm going to use the rotate command. I'm going to rotate that around. So just the top line, not both of them. Using the center point, I'm going to tell it that I need to move it 145.9177, like that. So although it's not lined up exactly where they have it, this is going to be the actual angle of where the helix is going to live. Okay, so now that I'm in 3D, I also need to throw in what my height change would be. So we know that the height change right now, we're going with 91 and 7/8. So I'm going to draw a line straight up in the middle at 91.875. And then I'm going to move this angle up to there, or that line up to there. So you can kind of see it starting to like take shape a little bit. There's just kind of like telling AutoCAD these are the points that I'm working with here. So I got, my start point, my end point. I know that these are lined up to 107 radius, like they're at 107 radius circle. My height should be correct. Angle should be correct. So then the next thing that you want to really do, then since you have that, is you're going to type in helix on your keyboard, helix, and you start by selecting the center point of the start point. So like center point of your base, just like that. And then it's going to ask you for your radius or diameter. It starts with radius, which is fine. So what I end up doing is just click on my endpoint, or I guess my start point there, because that'll determine that it's 107. And then it's going to ask you for your radius at the top, because you can actually draw it to shrink or grow if you really wanted to. But for our purposes, it's going to be lined up from top to bottom, so we just need it to say 107 again. So I can click on that point again right there. Then it's going to draw in this little slinky guy. So the slinky guy, we have to do some work on it still. We can't just leave it how it is, because it's going to end up drawing that like way too many times in a circle around that. So in order to get that to be the correct number of turns, or the correct like slope going up here, we need to tell AutoCAD how many turns it's going to make. So down at the bottom, you'll see down here in the Helix command, there is like a few different options here. That one that's second back there is called turns. We'll click on that. And right now it's set by default to 3. So how you determine the number of turns that you have to type into AutoCAD is driven by the angle that you're going around this circle. So what you do is you type in the angle that's 145.9177, and you divide that by 360. So that way, when you do that, what you're getting now in your calculator is, I mean, it's probably hard. I don't know if, I can't show my screen because I'm recording it through OBS, um, but when I take that 145.9177 divided by 360, that gives me a decimal that's 0.40532694444, which is what the number of turns is that you're making around that circle. So it's kind of confusing. It's not really a good way to explain that. At least I can't think of a better way to really explain it. But if I type in that number of turns there, 0.40532694444, then you can see now it's actually more lined up with where we need to be. I'm not doing laps around the circle anymore. I'm kind of where I need to be. So then the last thing you want to do is you want to click on your endpoint, and it's going to tell it how tall to make the helix. So we're going to stop right there. So now you can see we do have a helix there. And that number of turns is why this needs to be as far back of a decimal as you can go, because the more precise you are, the less likely your helix is going to end up going a little bit past this point. Or, well, it shouldn't go past this point, but there's a potential it could move past the stop point here by like a small bit. So the closer you can get to a real accurate decimal, the better off you're going to have a chance of this stopping right where it needs to stop here. Um, yeah, yeah. So it's confusing, but that really is like the key to making this work right, is knowing how to convert that angle into the number of turns that you're dealing with here. Because like the radius part's no big deal, and the height's really no big deal, but the math to get that to work is really, really important. So I'll go as far as it'll let me go. So like in AutoCAD, if you wanted to pull an angular dimension on something, like if I had a CAD file for this, Um, I would just set it to my precision is, where is my precision at? Oh, of course, now that there it is. Yeah. So I would do something like that and then divide this by 360 to get like as close to it as I possibly could. I mean, it's not going to be very far off, even like if I went 4 decimals out, but I don't know, the closer you get, the closer it's going to be. Yeah. I only say that because when I did Norfolk Stair, I remember Jake and Arthur were debating on this because I had some that were like less than it was like a 64th off or something, and Jake was all paranoid about it, and Arthur's like, 64th is nothing, dude. So, but I want to make sure going forward that as we're doing these stairs that we're making them as accurate as we can, because that way there's no concern about like, hey, is this right or not? Um, okay. So really then from there, all you really need to do when you go to do the sweep now that you've got the math part down and the helix part drawn, I mean, if you want to check it, you can. You can go top down and you shouldn't see any sort of deflection here between the helix and the circle. Like it should be, I mean, of course now it's doing it because I'm like zoomed in, I think, but it should be pretty spot on. Oh, mm-hmm, mm-hmm, mm-hmm. Okay. Yeah. Huh. Well, mm-hmm. Well, yeah, now it's basically the same thing as what you've already are used to doing when you do if you ever do like a sweep command, it's always going to make sure that everything's lined up perpendicular to your curve. So again, that's kind of where that angle line also becomes important too, because then you can use it to line up your profile with what you're dealing with. Um, so if I have it lined up now, what I can do is I can take that and I'm just trying to think, do I want to, well, we'll just do this for now. I was gonna say yeah, I was just thinking about that. Yeah, I was just thinking about that. I was hoping nobody would catch. Just kidding. No, I was just thinking about that because technically you're right. It should continue all the way down to the floor. So really, what I should probably do is extend my helix down another. What was the height of the tread? 6 and 9/16. So I'm gonna take this and make a copy of it down in the z direction. Negative, let's see, sorry, what was that again? Negative 6 and 9/16, so 6 and 9/16 downward. And then I should be able to actually extend that helix over. I don't know if it'll let me do it. Let me try it again. Extend. Whoops. Oh yeah, it did. I don't know if it worked though. That seems kind of weird. Like it extended it past. Oh yeah, you're right. Hold on. Let me go back. I got an idea. You had it right on the money, man. So like if I extend this down and it appears to be sticking out past, I can just go from the side and then change my change my view to be looking at that, and then I can trick AutoCAD into maybe working. Maybe not. Either way, like if I realized I kind of made a mistake like that, what I could do is I could end up oh, there it goes. I don't know why it wouldn't let me do it on the curve. But if I ever made a mistake like that, I could just kind of redo the helix math again and just be like, okay, well, I kind of want this to come down to here now instead. Um, so, um, yeah, and so right now I kind of just connected that dot from the endpoint, like the new start point here to the center of where I was previously. But you can see it's crooked, like the height is not right on this point. So what I need to do is highlight that line. And a lot of times with these helixes and things like that, you can go into here. I think Cody showed me this a long time ago, but you can actually change your end and start points for each point. Well, first I got to make sure I set this back to WCS, I guess, but you can change your, like my NZ is at 0 right now. And my start Z is at negative 6.5625, which is actually where I want that to go. So I can just change it there in properties and it'll change the one side but not the other. That's kind of neat. If you haven't messed with that yet, it's really kind of a nifty way to cheat the system a little bit. Um, so we'll align this back to where we were down here. So starting with that corner and then going to this corner here. Okay, so now technically, I hope that works out. I guess we'll find out. Well, I'm going to sweep this anyway, so let's do our sweep. Now you guys got me thinking, because that's the floor now, technically, this line here. All right, let me try this. That should work, but let's give it a shot. So I'm starting at the top now versus the bottom of where I was, which kind of makes more sense anyway. All right, so let's sweep it here. Take that profile. Oh, and sorry, one more thing. I didn't even think about this, but anytime I'm doing one of these, I always save backup copies in my CAD file 100% of the time. Yeah, if I ever get to like a checkpoint, like video game terminology, if I get to a checkpoint and I'm like, okay, I'm about to sweep this, but as soon as I do, this helix disappears. And what if I need it again later? So I'm going to save it over here. So let's sweep our profiles. And again, with sweep, you guys already know this, but anybody that doesn't know this already, the base point always has to be selected and the alignment always has to say no. And if you don't do the alignment, especially with something as complicated as this, like if you have it turned on to yes, it's going to mess it up 100%. Yeah, Jake and I were just having that discussion when he was doing the mock-up because he had to resweep something that he needed for them to be able to actually make the mock-up, like a like female male like platform or something to press it, and and he went to sweep it and it kept flipping in all different directions. I was like, you gotta turn that alignment off because yeah. So that's what we're gonna do. We're gonna slice it at the floor. I'm using a 3-point slice to do it, and we're gonna just take this and we're gonna tell it we only want to see stuff above that line. So now you can kind of see how it's dying into the floor like that. So, um, yeah, it does look really weird. It's kind of an optical illusion, but the reason why we're having such issues with the mock-up right now is because of this warpature, if you want to call it that. Because if you notice, one thing that's very unique about these staircases in general is just the fact that you got to think about it like this. As you're going up, each tread is flat from left to right. Okay, so as you're going up these stairs, this is on a very tight radius and this is on a very loose radius over here. So as you're going up, the slope is actually less over here. Like it's less steep over on this side and more steep on this side because it has to stay exactly the same height from left to right. Yep. So it's really weird and it creates such a weird twisting motion. But that is what's happening there. So if you see that, that's actually supposed to happen. It's not somebody didn't goof up or something. That's just how it is. It's just weird. So the inside is always going to have a steep slope, and the outside will always have a, um, I don't want to call it like a very not steep slope comparatively. So you got that. And then what I would say is if you wanted to go, yeah, mm, yeah, with viewing. Okay. Yeah, if that helps. Hmm. Yeah. So that's kind of the gist of drawing the helix part. Um, that part, it's really not too bad if you know, if you have like the mathematics to it, like if you know the angle, the height change, and the radius. Those three things, if you know what those are, that part's actually not very hard. Like the hard part really becomes like when you have treads or things like that, because now you have to worry about how to draw those in. So when you have something like that, what I found is that I like to use, again, make another copy here just for the fun of it. I think what I'm going to do, just to show kind of like how to make that happen, because they're weird angled, like these treads are going to be funky. I can trim these. I don't know why it won't let me do it. Jerks. Okay, let me see if I can get it to work. Um, yeah, the angled treads or the curved treads are kind of goofy too. So that's something else to kind of have to you have to kind of think about too as you're drawing something like this. Um, if you want to draw in those treads and you want to make them as accurate as you can, um, I guess let's see how far is it from the outside to the inside because like that. Okay, so like four. Oh, I think it's supposed to be 4 inches there. I think it's just giving me a weird number. Yeah, it's 4. So if I offset this yellow line in those 4 inches, and then I take the next point over here, and I go from inside to inside. This is going to be where the treads live. It looks like it's 54 inches wide. So if I offset these 54 inches in, I'm just kind of creating like the footprint of where the treads are going to end up living. So this is my stringer, and then this is where my treads go. So then from there you can use one of those array paths or path arrays, whatever you want to call them. I typed it in wrong so many times that AutoCAD just knows what I'm talking about, even though it's not right. So, okay. So we'll do one of those. I had to trim my circles or my arcs to like, or circles to arcs so I could tell it how many treads I need. So um, going back from the top down, let me see here. How many did we have again? You were 13 plus the landing? Okay. I think I deleted it a little early. Okay. Or, well, well, hold on. 1, 2, 3, 4, 5, 6, 10, 11, 12, 13. I think, oh yeah, 14 is the landing. I'm sorry, you're right. Yep. So if I tell it I need 14, well, I would need to tell it 15 lines, so I have 14 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 there. Cool. Okay. So then one thing, yeah, yeah, that is true. So maybe we need 16 because we would be starting here, not here. This is an imaginary step. That's actually the floor. Yeah. So technically, yeah, you're right. I mean, this isn't 100% right, because I think this is actually a little bit less than a full tread. So I guess what I would try to do is if I knew exactly like start point of the treads, I would try to use that to start drawing them in. Um, hmm yeah. So then the next step would be like I like to do these with blocks. Um, so I do model the first tread by itself, and then I will convert it to a block, and then I will just go ahead and copy that block up the stairs all the way up, and just keep realigning it every time I go up a step, so that way they all go together. The reason I do that is because if there's ever a change to it, if they ever add like one of those little visual breaks, like the little transition strips or something, or they change like anything about the profile of the stair at all, it's going to make it way easier for you to change it once and just be done with it. Whereas if you just model the step and then copy the step without putting it into a block, then you kind of have to either modify each step or you have to delete each step and then recopy and paste them all the way up. That's kind of annoying. I've been there before, so word of advice, try not to do that. Okay, but these steps here are pretty basic from what I've seen. I mean, these may not be 100% accurate, but they just look square on the front, like based on what I'm seeing here. Like there's no nosing or anything, which probably isn't realistic, but we'll just say that that's actually right. Like that's what they want. So then I can press pull up my first tread, which again was 6 and 9/16. Just for showing it as a block, 6.5625. What I would probably do then, well, hold on, before we do that, sorry. Treads are usually going to be made out of solid. This one's actually concrete, so we're not actually responsible for the tread. But just so you guys know, if you haven't drawn stairs, which I think all of you guys have, but if you haven't drawn stairs, what we'll always do is we'll make the tread at 3/4 thick, but we'll make it with a 1/2 inch of plywood and a 1/4 inch of actual solid anytime that we'll do a staircase like this. So I'll just draw it at 3/4 right now. I'm going to take a line straight down at 0.25 and then just slice that bad boy. Yeah, on this one for this is AbbVie, right? It looks like it's all concrete, so that won't be us. That's what it looks like. Yep. That makes it a little easier though, right? So yeah. So I'm just kind of doing the same thing here, just to visualize what the stairs will look like. Dang it. I'm taking these and I'm slicing them so that way what I can do is now align this with the front of that step and then just miter them together just for the purpose of showing like how you would handle it if it was a solid stair. Um, I realize these are concrete, so really this isn't really a necessary step for this particular staircase, but I don't know if Cody's has, I can't remember if his had treads or not, so I just want to show it. That way it's at least somewhere for people to see. Um, so I got these two right where they need to go. I'm going to use the interfere command, and I'm going to kind of get that little piece of material there that I need to be able to slice this accurately. And then before I close that, I just need to make sure I uncheck delete interference objects. That way it's no longer going to delete that. And I just need to now slice all of these parts like this. Grabbing 3 points on that face. I can just delete all the extra junk. So that'll work. It'll give us at least our kind of step construction there for the first tread. And then what I usually do is I'll put these on different layers too. I mean, you can do it however you'd like to do it. I usually like to keep them on different layers. Like I'll have a solid layer and like a substrate layer. It may not be necessary, but I kind of like having that all separated out that way. If I need to modify something later, it's easier to really get to that. Um, let's see. Now the yellow line was oh yeah. No, it makes a big difference, especially with stuff like this. But yeah, just we'll do that real quick. All right. Oh, well, I don't have those layers set up, so I'll just skip it for now. Sorry. I lied. Oops. All right. So I forgot I wasn't working in a template. So tread, let's name my block tread because I mean, or I could just name it step or something. I'll just leave it a tread. I'm gonna pick a base point on it. This I'll grab like maybe this guy here. Doesn't really matter too much because you don't need that to align it. You want to make sure you grab all your parts. Hit OK. And now you have a illegal block because it's 3D and they don't like you to do that, but whatever. So now it's a 3D block, which you can actually work with. Yeah, it's funny how that works. But so what I would do with that then, okay, so we know I probably should have extended that out further, but we'll make it work. I need to align the front of this riser with the back of the previous tread like that. You can see I goofed up right here because this needs to actually extend underneath of that. Um, so I could fix that real quick. It's not a big deal. Um, I just need to modify the block. Now, when you go into block editor, you can't use press pull or anything like that, unfortunately. So like for our purposes, like what I have to do is take a copy of the block, explode it, change the geometry of it, and then copy this into the block editor and delete the old 3D parts that are in there and just replace it. Super annoying, but it works. There we go. Okay, so let's copy this. Go back into here. Double click on our block, open the block editor. You can actually rotate your view into 3D space, but you can't do anything else really in 3D in here, unfortunately. So what I'm gonna do, oh, that's right, I can't even use the align command. I forgot about that. They have it blocked off where you can't use it in here. Yeah, that's what I'm gonna do is actually move them at the same time so I can kind of like see where the one was and just cheat it and paste it there and then just delete the old one. Now I can save it. And did I fix it? I don't think so. I don't know why that didn't. Did I not press pull it all the way? Like what happened? All right. Let's see. Why did that not work? I think maybe it moved it in versus out. Gosh, I see that. I'm gonna try it again. Sorry, guys. Yeah, it was a matter of that. I just didn't really get that done right. So now it should be okay. Oops, hold on. Make sure I grab the actual endpoint and not some random perpendicular point. Okay. Yeah, so I know it's a struggle, but I definitely recommend blocking these as much as you can. Yeah, I got it now. But definitely recommend it because like I have been there before where I haven't done that and then it becomes more of an issue because you gotta then modify each thread if something does need to change in the model because I messed it up. Yeah, I did that on purpose, right? Yeah, yeah. So really, it is tedious to do it that way. But I will tell you though, it does make a huge, huge difference when it comes to like being able to change a model after it's done if you have to. I mean, luckily, most times you won't have to, but you never know. Um, Here, I'm just gonna do a bunch of these right now. because ain't nobody got time for that. These are old tricks I used to learn from when I worked for that old commercial roofer that had been using AutoCAD forever. It's like using your base points to align or base points to copy and paste because it really speeds things up. Like I was able to just move or copy 3 of them. Anyway, once you get to the end though, I'm going to show you one more thing and then we can call this done. Because there's one more thing that is going to become somewhat of a task. And that is going to end up being, I need the back point, not the front point. When you have to notch your stringer panels, if you have stringer panels. When we did Norfolk, we did have stringer panels and we also had risers and treads. So when we did that, we had to, oh, I'm like 2 away. All right, when we did that, we had to slice a bunch of times to do that. And I think there's probably a better way to go about it. You could probably use like subtract or something to make it work. But here, let me just do these last 2 real quick. There we go. Okay, so now we got the treads in there. That one's actually the landing. We got to keep that in mind. But we got the treads in there. I can unhide and bring all my stringer panels back, or did I not hide them? I didn't hide them. I just moved them off to the side. So we'll copy these back. And then we're going to do some notching of the stringer panels. And then I think we'll be done with this because really the only other things that you would really need to know are like, again, you could sweep like the handrails and stuff if you needed to, but that's going to rely on the same exact like math as what we did to get the, yeah, like that. Yeah. So you got those in there. And well, depending on how this interacts, like if the treads die into the side of that, then you don't have to notch it. But if they need to go through and these panels need to like stop on top of the tread, then you would have to notch those. And that would be kind of a tedious. But if you had to do that, what I would suggest is doing something like this. Oh, isolate. All right. So if you had to notch the stringer panel to the top of the tread and the front of the riser, what I would do is I would use slice here. Is what I used to do when we did Norfolk, was I sliced everything horizontally like this, keeping all of those stringer panels like where they are. I just worked my way down each step one at a time, and I would do a horizontal slice through each of these. Once I had that horizontal slice through there, it's going to look like sort of like this, like where it looks like almost like fish scales or something weird. So then what you do from there is if you had to notch it down the front around the riser, oops, slice. I don't know why I keep typing that in wrong. Okay, so slice, we're going to do, again, 3 points down to here. And then over to here. And then you just kind of want to keep doing that all the way down. I'm only doing it on like 3 stairs because I'm going to save you guys the the headache of having to watch me do that. Yeah, you could do that too. That's a good point. You could honestly do that if you'd like to. And then just union them back together when you're done. That'd be a good way to handle it too. But if you do that and you're like, okay, I don't need these anymore, these go away. I mean, this is a really bad example because I did not plan that. Um, yeah, yeah, yeah. Like if I really was gonna do this legitimately, I would have extended these out underneath of there a little bit more. That way, these stringer panels all kind of match up with it better and they butt into it versus being kind of like at a weird kitty corner like this. Um, but yeah, you can do that if you need to notch stringer panels around a stair. I usually just horizontal slice everything and then vertical slice the front part where the riser goes. But like Cody said, you could also do like that copy paste method and then union it all back together at the end. That's also a good way to do it. Um, yeah, so I think so too. I think I did something bad there. I don't know what I did, but something wasn't quite right. I think because I didn't have the treads in there when I made my section view, I didn't really notice that, but yeah, there's something weird with that that isn't right. Like realistically, what that would mean is that either like this probably either needs to come up or the treads need to go down, but I don't think the treads can go down, so the stringer cap would probably change maybe, but I don't know. It depends on like how it plays out. But yeah, it shouldn't really look like that. Really, it should be more like what's going on here, where there's like a couple of inches in between the top of that tread and the start of the cap. So, um, but yeah, if you were gonna try to do something like this handrail in 3D, I would do the exact same thing. You want to find your start point, your stop point, and then find the height change in between, the radius that you need for that handrail, and then also the angle between so you can calculate the number of turns that you need it to go. Um, I don't really think we need to draw the handrail because I think it's all metal by somebody else, but if you wanted to go and do that, you could. It's just something else you could throw in there too. Um, but really, I mean, they're really they look scarier than they really are. Like I tell everybody, it's really not that bad once you understand how to do it. It's just the problem is most places, whether it's online or in books, don't really explain how that works. Like how do you get that helix even drawn in the first place? Because that's the hardest part. The rest of it's just like basic 3D modeling that you already do every day. I mean, so um, I know you guys all know how to do that. And the helix part, I mean, it's using sweep, which you already know how to do, but the helix is the hardest part because it's like, how do I do that now? So, um, yeah, you just got to know how to do the math. Got to know that everything needs to align. Like you need to be perpendicular to your helix when you sweep. Any sort of like variation there, of course, is going to distort the profile, and you'll end up like Synergy, name drop. Um, you can't do that. You need it to be perpendicular, and you also need it to be vertically up and down to that curve, because otherwise it will get distorted, and you don't want that. Um, I promise you, Jake will come knocking at your door and be like, "Why did you do this?" Um, so yeah, really, really important stuff. When you go to do like the landing and all that too, it's gonna be pretty much the same as like if you were to miter something on a desk or something, you're gonna take those two sweeps, you're gonna push them together, and then if you need to make a miter cut or something, you could extend one and then use like your interfere to get that slicing plane through. Like for example, like if this wasn't straight up and down, which you can tell right here, I don't think it's supposed to be because this is lower than that. They probably messed that up because I'm sure it was supposed to go like this and follow that curve until it hit there and then miter from there to there. But yeah, that would be like the same type of thing though. You just overextend it, line up the two profiles, use interfere, keep the interference geometry, and then just do your 3-point slice, chop it off, delete anything you don't need, and then that's pretty much it. Um, so there's a lot of steps. Yeah. Mm-hmm. Yeah. I think what I would do in order to break those up, because I think we're gonna either do a spline reveal or we're gonna end up doing a full depth reveal. Like that would be like the two that I could see us doing down here. What I would say is if you know, I guess again, the start and stop point of that panel. So like in our case here, if I take those two pieces and I'm gonna again copy it off to the side. So those are just the underside panels right there by themselves with nothing else. And then that little circle that we drew. So if we start at the center point of that circle and we take a line straight out to here, that's exactly where that panel meets the ground. And then we would also do the exact same thing that we did before when we were trying to draw the helix, but we're kind of reverse engineering it now at this point. So what I'm going to do is take a point from the bottom of my panel here to the center of my circle here. I'm going to highlight that because as of right now it's coming down at an angle. But I'm going to go into my properties and I'm going to tell it that the height of my start Z needs to match the height of my end Z here, like that. And then what I would do with that information, now that I have that, well, I guess maybe that's kind of not needed. Maybe I should bring that down to here. What I was going to say is like if you know that, just like you were, or if you were doing panels on a wall and you were trying to evenly space all of your reveals, what I would say is I would take the outside edge of each, like where the panel stops. Let me get that here. Whoops, I extended it the wrong way. Oopsies. I'm going to trim that back. Okay, so if you were doing this in, the sense that, hey, I know I'm going to be doing like a 1/4 inch spline reveal, you would still want to do what we always do, where you offset the endpoint a 1/4 inch off the path, so 0.25 this direction. Make sure that's right. It's so hard to tell sometimes unless you zoom in. And then same deal here, 0.25 out in this direction here. So then, because if we're assuming that the reveal is a 1/4 inch, we also need to offset a center point. We're going to go 0.125 this way and 0.125 that way, which will end up being like the start and stop point of our array path that we use to draw the different reveal spaces there. So it's kind of end up being just like you would do for a panel set, just a little different because you're dealing with something on a weird curve, but you're kind of treating it the same way because really it's not too different than what we're used to seeing. So trim your path back to the midpoint of each reveal, and then use your array path command, highlight your line, and then you just need to break it up. I probably should have actually made my path be like this edge here so I could get an actual accurate panel width on the outside edge. But I have it like 4 inches over here. So it's not a huge deal, but I want to make sure that those panels don't exceed 4 feet in width anyway. Just like you would for a wall panel set, it's going to be the same exact thing. So if I can get those less than 4 feet, and I guess the tricky part here from our side is that we want to make these perpendicular to that curve now, right? Not like parallel to the ground, because those reveals aren't going to be, they're going to be like going with the panels, not like straight up and down. Yeah, that's a very good question. That is a very good question. I think we could come up with a way to do it. I just got to figure out how I would do that. I almost feel like what I would do is maybe take a helix from that point to here, um, which, yeah, I think that's how I would probably do it to get it to be perpendicular to the panel versus the floor. Um, you could probably also do one of these extract edges numbers, like up here, which should give you that helix again, unless it turns it into a spline, which it looks like it did, unfortunately. Dang it. I was thinking maybe that would be an easy solution to that, but hmm yeah, you could go for it. I mean, it's not like I would say this particular example isn't exact to what it's going to end up being because one, we don't have the metal shop drawings yet, and two, we don't have like the actual CAD from the architect. So anything that we're doing, I would more rely on those two bits of information more than this PDF here. But because it's all that I have, I'm just showing you guys like how I would handle like drawing this, pretending that I have that information too, even though I don't. So, um, yeah. And realistically, this is pretty close anyway to what it would be. It's just, you know, I would be more comfortable knowing more of what's going on for the steel, more of what's going on for like the actual like CAD from the architect, so I could actually confirm that radius is 107 and not like 108 or something. Um, yeah. So, hmm hmm Depends on the case. I mean, I do like the question. It's just a lot of times we do try to get those CADs ahead of time, or if we have to get like a laser scan of the space, usually that's something that we do look at too. Um, just in the case of the one that I'm working on right now, I could show you kind of like what Eddie was able to obtain for us for it. And a lot of times this might end up being what you actually need to actually work with. So what I found with these stairs though is a lot of times I will draw a preliminary model for it, which goes through the whole red line phase, through the drawing phase, all that stuff. Once they do their markups, usually at that point, the project manager is able to get a laser scan of the space or at least some way to get measurements for you from that space. And then you might have to remodel it based on that, which kind of stinks. But once you draw it the first time, it's a lot easier the second time, and I can promise you that. It's just the first time you do it, it's scary because you're not knowing what you're dealing with, and then the second time it's like, okay, I've done this before, I got this. Um, so a lot of times you end up drawing it twice. The first time is kind of a practice. I mean, you want it to be as accurate as you can, um, but a lot of times it actually is more of like a practice one because it's like, hey, this is what we're thinking about doing. Are you good with this? And then by the time you actually get the laser scan or something, then you have to kind of work based on that versus what's on the architectural drawing. Sometimes you luck out and actually they might actually be exactly the same. Like for the case of what we did with Sage, Sage actually was like that, where the CADs or the architectural drawing was actually spot on with what the steel vendor was doing. And in that case, we were able to like just pretty much not have to redo it again, which is really cool. Um, hmm Yeah, that's all built into it anyway because there's pretty much always going to be a need to draw it two times. One just for the sketches, the shop drawings, and then two for like the actual incorporating of the field dimensions. So it's kind of uh, it's very time consuming to do it that way, but by the time it gets approved and all that, and we get those either a laser scan or a CAD from the steel vendor, it's like that actually makes things way easier because then you can really just work off of what they give you versus trying to use an architectural drawing and try to make ends meet because sometimes they don't have like in the case of this one I had a lot of like conflicting things like reveals that were shown at a quarter and then shown at a half in a different view and like okay. But yeah, that's a whole different story. But like yeah, usually by the time you've drawn it the first time you submitted it, usually takes time for them to approve it or deny it, whatever they want to do with it, mark it up. And then by the time you get to your round two where you're about to draw it again, we usually try to press to get something like this from the field. That way it's not like you're working with just guessing to make sure the information's right. Like this is going to give you 100% spot on. This is exactly what's out there. This is what I'm building around. And if there's any conflicts, I can find it now. And if not, then this just gives you like the kind of the key to go off of. So um, yeah. And I told Eddie he needs to hang on to this vendor specifically because like they did an excellent job of giving us a 3D model of what's out there. We've had other vendors that just do like a point cloud, which is fine too, but it's harder to work with. We also had people that do like individual points, like Richard Green had done that for me once, and that was very, very hard to work with too because I didn't really know what I was looking at. So, but yeah, something like this. I always try to press for this because like this is like best case scenario. If you can get a model from a laser scan guy, that's actually exactly what you want because it's going to give you 100% like what you're matching up to. Um, so again, that's for a different staircase, of course, but it's still something that is really important to get, especially if you want to make sure things are actually going to work out okay. Um, Trying to think if there's anything else to really look at with this. I would say one other thing to keep in mind too is if you are going to draw a staircase, but it's specifically like a spiral one, but even just a regular one, I would always run it past Kevin and listing too, like Kevin and the listing department. That way they can get their eyes on it too and let you know if they have any pointers or things that they want to see different. Um, I always talk with Jake about this stuff before I draw it because it'd be better to catch any issues now before you model it. Like in a case like this was something Jake and I questioned and we had to rely on Kevin's feedback for was are we able to miter a corner on something like this? And Kevin was like, God, no. So that one got ruled out real quick. Um but yeah, anytime you're drawing something crazy like this, make sure to try to pull one of them over so you can like at least get their thoughts on it. And maybe you don't get an answer right then and there, but maybe you get some feedback and then you will won't have to risk or having to remodel something later because they've already approved it or kind of get their input on it for you. All right. Anything else you guys can think of question wise? Anything like that? Okay. All right. Yeah, that was, yeah. I mean, never done it before, so you guys are like the guinea pigs here, but I appreciate you guys stepping up to help with this because, like, honestly, I couldn't do it without you guys. Um, There's way too many spiral staircases for one year for one person to do them all. So, um, yeah. But you know what though? This is gonna help you guys out too because then later down the road, you'll know how to do this in case you ever do wanna try it out again, or if you wanna step it up and help out with another one. Mm-hmm. I'll put one in your house. Yeah. Oh, yeah. Hmm. The math behind it. Right. Yep. Crazy. Well, I mean, just like the slope, like you said, it's like just like the slope. Like, just imagine this being like, this would be a lot slower and this would be a lot faster because it has to keep up with the inside speed. Hmm. Yep. Well, all right. I'm gonna save this recording. I will put it up on that cool little YouTube channel, but I'll save it in the engineering drive here too. Um, yeah, I know it went a little bit long. I mean, we're at an hour and 20 minutes, but for a spiral staircase, I think that was a pretty informative one. I mean, it takes time to get through that stuff. It's not like a boom, you're done sort of thing. It's like you have to go through all of those steps. So, all right. Let me stop this recording. I'll save it here.